Good morning, students. Today we are going to discuss about applications of echo and applications of reflection of sounds and the Doppler effect. Okay, students, right? So in last class we discussed what is echo and what is the principle used in echo, right? Therefore, today we are going to discuss about applications of echo. Okay, students, right? Shall we go to the topic? Okay, the first one is applications of echo, right? See this: to find submarines from surface ships, right? So echo is used to find submarines, right? And second one, in fishing boats to find large flocks of fish. Yes, to find out that uh, group of fish, that is fishing zones, right? And next, to measure the depth of the sea. The echoes is used to measure the depth of the sea. Okay, and this echo is used to locate a sunken shipwreck or cargo. Yes, to locate the cargoes. Okay, students, so these are the major areas. Yes, echoes are used. Okay, right. See this: to find the submarines from surface ships. See, so with the help of sonar, right? See, the sound waves are transmitted with the help of transmitter to the surface. Is there any submarines? So that submarines reflect the sound waves, and the reflected sound waves are reach the again the receiver. So the distance between the yes submarines and yes to the ship will be calculated based on the yes time taken by the sound to reach the object and return to the receiver. Okay, okay. So with help of the yes time, then only they calculating the distance between the submarines will be calculated. So echoes are used in to find submarines from surface ships, right? Okay, students, right. And next, see this: to find is the fishing zones, right? See, returning echo, this is pulse of sound and pulse process. That is, the echo pulses are transmitted to the surface, that is to the surface of the sea, and that surface reflect the echoes, and that echoes are again reach the receiver. Yes, so the time taken between these two will be calculated, and to measure the depth of the sea also will be calculated. Okay, students, so what are the applications: to find the submarines, and to measure the depth, and to find the fishing zones. Okay, that means the density of the fishes. Okay, these are the main applications of echo. Okay, students, right. Now come to this one: calculation of speed of sound, right? The sound pulse emitted by the source travel the sound pulse emitted by the source travels a total distance of 2d while traveling from a source to the wall and then back to the receiver, right? And the time taken for this has been observed to be t. So hence the speed of sound wave is, yes, the speed of sound wave is given by distance traveled by time taken. The speed of sound is equal to distance traveled by time taken. So what is distance traveled? 2d. Yes, therefore 2d divided by time taken. It will take some time now, so that time is equal to t. Okay, students, right? So the speed of the sound will be calculated, yes, distance traveled by the sound by time. So 2d divided by t, right? This is very very important, yes, formula to calculate the speed of the sound. Okay, right. Next, applications of reflection of sound. Yes, the first one is soundboard, right? See this, these are basically curved surfaces like concave surfaces. You know the what is concave, right? Okay, which are used in its auditoria and halls to improve the quality of sound. So these soundboards are used in auditorium. Auditoria is nothing but auditoriums, right? Okay, right. This board is placed such that the speaker is at the focus of the concave surfaces, and the sound of the speaker is reflected towards the audience, and thus improving the quality of sound heard by the audience. So these are the soundboard. Okay, so this is one of what, this is also soundboard. Okay, total soundboard recording system. Okay students, okay, these are the soundboards to control all the controls in this board. Okay, okay students, right? Okay, next application, ear trumpet. So ear trumpet is a hearing aid which is useful by people who have difficulty in hearing, right? So it is useful for difficult in hearing. Yes, in this device one end is wide and other end is narrow. The sound from the sources fall into the wide end and are reflected by its walls into the narrow part of the device, right? And this help in concentrating the sound, and the sound enter the eardrum with more intensity. Yes, so this enables a person to hear the sound better. Okay, so this is the instrument. See this, this is that ear trumpet. So one end is wide, another one is narrow. Okay, the sounds are instant on this walls, and finally high intensity sound reach our ear, yes, for better hearing. Okay students, right? Okay, right. Next, megaphone. Yes, see this, a megaphone is horn-shaped device used to address a small gathering of people, right? And its one end is wide and other end is narrow, right? And when a person speaks at the narrow end, the sound of his speech is concentrated by the multiple reflection from the walls of the tube, and thus his voice can be heard loudly over long distance, right? And see, this is that, yes, that megaphone. So one end is wide end, another end is what, narrow end. The sounds are instant on this walls and reach the long distance, right? So this is that megaphone. So what are the applications of reflection of sound? Three applications now. What are the applications? First one is soundboard, second one is ear trumpet, and third one is megaphone. Okay students, so three applications, right? Okay, and the next, Doppler effect. The next topic is Doppler effect. So Doppler effect is important question. Okay, right. Doppler effect. See this. What do you observe when you throw a purple into a body of water? purple into a body of water. Yes, apart from the purple sinking, right? What do you observe when you throw a purple into a body of water? Yes, what do you observe? See that, what do you observe? Yes, something happened now. Yes, do the things and observe that the things. Okay, now see this Doppler effect. Doppler effect explained why we perceive as a change in frequency when the wave source approaches or retreat from us. So here sound waves. So Doppler effects which related to sound, right? Therefore, yes, what is Doppler effect? Right, see, Doppler effect is the change in frequency of a wave for an observer moving related to its source. Again telling, Doppler effect is the change in frequency of a wave or sound for an observer moving relative to its source, right? Okay, now the observer observes an upward shift in frequency when the wave source is approaching. Yes, okay. So listener, yes, observer is the listener, and source is that a device which produces sound, so that is the source. Okay, right. And a downward shift in frequency when the wave source is retreating. Okay, so frequency variation, right? Okay, I'll tell you in clear way. See this, Doppler effect applies to all waves including sound waves, light waves, water waves. Apply this effect is applied for all waves. Okay students, sound waves, light waves and water waves. Okay, right. See, small introduction about Doppler effect. See, Doppler effect is originating in 1842 by an Austrian physicist, Christian Doppler. Yes, Christian Doppler is proposed Doppler effect in his article. Yes, the article name is Über das Farblich der Dopplerstein and Integer Andrea is Gestrei des Himmels. Okay, translated, that means on the colored light of the binary stars and some other stars of the heavens. This is that exact meaning, yes, of this sentence. Okay students, so Doppler effect discovered by Christian Doppler. Okay students, see, this is the picture of that Christian and Doppler. Okay, right? Okay, concept of Doppler effect. To understand the concept of Doppler effect, we must first understand the following things. The things are wavelength and the frequency and velocity, right? You should know what is frequency and what is wavelength and what is velocity. Then only you have to understand the Doppler effect. Okay students, therefore first we are going to see the wavelength. Yes, if you consider wave, yes, transverse waves, the transverse wave produce the crest and trough. See, this is crest and this is trough. Yes, the distance between any two crust or the distance between any two trough is nothing but what? Wavelength. That is, see this, the distance between two successive crests of a wave, especially points in a sound wave or electromagnetic wave. Yes, if you consider sound wave, yes, that is also distance between two successive crests, right? Okay, or otherwise the distance between two compressions, right? That is the wavelength. The wavelength is nothing but lambda, which is equal to nu divided by f. Yes, sorry, v divided by f. So here lambda is wavelength, v is the speed, and f is the frequency. V is the f is the frequency. Okay, students, right? And the next frequency. See this one, low frequency here, medium frequency here, high frequency. What is the difference between these three? The number of peaks is very high now. Yes, that's why this high frequency. Therefore, see this, the number of, yes, occurrence of repeating event per unit time, or otherwise I'll tell you simple way, number of peaks per second, number of peaks per second, that is the frequency, right? That is, see this, in terms of waves, it is the number of waves passing a given point per unit time. The unit of frequency is hertz, that is equal to f is equal to v by lambda. Frequency is equal to v by lambda. Okay, students, right? Okay, and the next, yes, velocity. See this car moving with 40 meter per second velocity, and this car moving with 30 meter per second, and both are moving in same direction, right? So therefore ms power minus 1 is the unit of velocity. No, that's why, see this, the speed of something is given by direction. Yes, the velocity is equal to rate of change of displacement. That's why displacement by time, the displacement taken as t and time is taken as t. Therefore velocity is equal to rate of change of displacement. Okay, d divided by t. Okay, students, any doubt? So we discussed the frequency, wavelength, and velocity. Okay, now is concept of Doppler effect. See, sound waves. See, I'll tell you a small example. A siren on a police car emitting a uniform series of sound waves, right? So siren is the source, that siren only produces sound. Therefore the siren of a police car emitting an uniform series of sound waves moving away from the source in all directions, right? Just in a distance away observing. So just we are standing near the siren, so we are the observed, right? Therefore in the sound waves, air is stationary. Air is stationary. Okay, students, so variation of sound will be takes place, right? Okay, okay, now come to the Doppler effect. See this siren sound. The Doppler effect causes the changing pitch of a siren, or when a fire truck approaches, the pitch sound higher than normal because the sound waves crest arrive more frequently. Okay, students, and when the fire truck passes and moves away, you hear a drop in pitch because the wave crest are arriving less frequency. So when the fire truck move towards you, the sound variation will be higher. Suppose the truck is move away from you, yes, there is a sound variation, right? Therefore the frequency variation takes place now, so that one is nothing but Doppler effect. Therefore the change in loudness is not the Doppler effect, it is the shift in frequency. It is different the frequency, that is a frequency variation, that is frequency variation. Okay, students, right? See this characteristics of the Doppler effect. Some characteristics. See the first one, if two objects are approaching each other, right, or if an initial object is approaching a second standing object, the pitch is higher. So we pitch is nothing but high pitch, low pitch. No, in songs sometimes the singer using high pitch, the sound will be high, Yes, or if you the low pitch, the sound will be low. So pitch is nothing but variation of sound. Okay, now see this. If two objects are moving apart, or if an initial object is moving apart from a second standing object, the pitch is lower. So there's the pitch variation. These are the two characteristics of a Doppler effect. Okay, students, right? General Doppler effect, variation in frequency, right? So therefore f dash is equal to v plus vs. So vs is the source, s means source velocity of sound, yes, and v minus v naught observer. V naught is nothing but observer, and f is that original frequency. This is the important formula, so please note it down. Okay, students, right? This equation apply to all four conditions mentioned previously. I'll tell you the four conditions, okay, later. Now see this, the sign of vs and v was depend on the direction of velocity. Okay, right? A positive value is used for motion of the observer or the source towards the other, and the negative values is used for motion of one away from the other. Okay, students, so there are four conditions in Doppler effect. Okay, I'll tell you later clearly. Now yes, come to that Doppler effect. Yes, in our book, see this, the whistle of fast moving train appears to increase in pitch as it approaches a stationary listener, and it appears to decrease the train moves away from the listener. So this apparent change in frequency, see this, the apparent change in frequency was first observed and explained by Christian Doppler is in 1803 to 1853, an Australian mathematician and also physicist, right? And he observed that the frequency of the sound as received by a listener is different from the original frequency produced by the source whenever there is a relative motion between the source and the listener. Okay, so this is known as Doppler effect. Okay, students, so there is a frequency variation between what, source and the listener. Source and the listener, this effect is nothing but Doppler effect. Okay, students, right? So please underline the definition. Okay, students. Okay, now this Doppler effect or the motion between that source and the listener, and the motion could be due to various possibilities as follows. There are four possibilities. The first one is the listener move towards or away from a stationary source. Suppose if you are standing in a railway station, okay, right, the train is sorry if you are standing in the railway station, if you moving towards the source, right, that is the first case. The listener move towards or away from the stationary source. Okay, see the second one, the source move towards or away from the stationary listener. Suppose you are standing in railway station at particular is point, the train comes to the station and is and away from the station. Yes, just imagine. So yes, train is a source and you is the listener. Okay, so second case is source moving or away from the listener. Okay, students, but this side listener moving towards the source or away from the source. Okay, students, right, and see the third condition, both source and listener move towards or away from each other. So both train and yes passenger move towards the, yes, both are moving or yes away from that in opposite direction. Yes, so both source and the listener moving towards or away from one each other, both are moving. Okay, suppose you are training is train moving in each direction and listener moving in this direction. This is also which effect? Doppler effect. Students, right? See the last condition. The medium moves when both source and the listeners are rest. Air medium only moves, both train and what? Train and the passenger are at rest. So these are the four yes possibilities in Doppler effect. Okay, students, four possibilities. Okay, so first one is listener move towards the source, right, or away from the source. The second one is source moving to the listener or away from the listener. Okay, and third one is both source and the listener move towards or away from yes each other. And the fourth one is the medium will move when the both source and listeners are rest. Okay, students, this is also 1 mark and 2 mark question. Okay, students, right. Now come to the definition. So please underline the definition. This is the definition. So please underline. Okay, students, see this. Whenever there is a relative motion between a source and a listener, the frequency of sound heard by the listener is different from the original frequency of sound emitted by the source. This is known as Doppler effect. Okay, again I'm telling, whenever there is a relative motion between a source and the listener, right, and the frequency of sound heard by the listener is different from the original frequency of sound emitted by the source, and this is known as Doppler effect. Okay, students, right, important definition, 2 mark question. Okay, students, right. And see this, suppose this is the source, let us assume this is train and this is listener, yes, suppose yourself. So source and the listener, see this n and n dash is the frequency of sound produced by the source and sound absorbed by the listener. So n is the frequency produced by the source, n dash is that frequency of s sound absorbed by the listener. Okay, so then the expression for apparent frequency, that is n dash, is v plus vl, is that velocity of sound plus velocity of sound in listener and velocity of sound in air minus velocity of sound is for source. Okay, therefore v is the velocity of sound waves in the given medium. Let us consider different possibilities for motion of all sources and the listener. Okay, students, so this is the general formula. Yes, n dash equal to v plus vl divided by v minus vs into n. S is the source, L is the listener. Okay, students, right? Okay, students, today class is over. Okay, we'll see on next class. Okay, that means we'll see on next video. Okay, students, please go through the yes topics. Okay, and underline the 2 marks and important statements. Okay, students, then only you will understand. Okay, students, see you on next video. Thank you.